Welcome, class. My name is Tom Mahoney. I'm your instructor today. Once again, today we're going to discuss how to get the aircraft from altitude down to a position that we can actually land it on the approach. So set up the approach, and briefing prior to top of descent is what we're going to call this lesson. We're going to use the following procedures to descend from cruise altitude to a point at which the final approach segment begins. We're going to have 4 steps involved. One is going to be A, CFI home. Step 2 will be determining the final approach speed. Step 3 will be calculating the top of descent. And step 4 will be building a 6-mile ring around our final approach fixed location. Start these 4 steps approximately 15 minutes prior to reaching your top of descent location. For this lesson today, we're going to be starting out as if we were on a flight from Salina, Kansas to Denver. The aircraft is approximately 20 miles from Othi. We'll go over here and find out if that's true. Click on the legs page. Yep. We're about 20 miles from Othi. We can see that right now. We are currently at flight level 280, as depicted here on our, actually it's right here, that's 280. We know we're at 280 because it says altitude is captured. We are cruising at 190 knots as shown on our speed tape. So there we are. That's what we're doing. That's where we're at. So you should be all orientated now. And let's move on. So there are 4 steps as I indicated. Step 1 is to know this particular acronym, A, CFI home. Let's take a look at what that acronym means. First of all, it says A, and the A stands for ATHOS. So the first thing we're going to do before we do anything is call up and get an ATHOS. We will do that through our ACARS communication system in the aircraft, and that will give us the most current weather information for the airport. So the runway you may or may not have loaded up prior to departure may or may not actually be the runway we're going to use, as we might be an hour down the road, the weather's changed possibly. So at any rate, the first thing we're going to do is call up the ATHOS to get the most current weather information we can. Today, we just happen to have pulled up this ATHOS for Denver en route to Denver, where it says ATHOS information X-ray, and the winds today are 170 degrees straight down a runway, I hope. 12 knots, gusting to 20. Decent day out there other than the winds. Looks like it's 10 statute miles. A few clouds at 9,000, 16,000. Broken at 21,000. A temperature today of 20 degrees. And we can expect a visual approach to a runway here. I've been here before. I'm going to guess it's probably going to be runway 17 left. Then we have a few other items on the ATHOS that don't particularly affect us at this point in time. So that's what we do. We get the ATHOS, we go through it. We determine from the ATHOS, between the 2 pilots involved, that we are actually going to use runway 17 left. Unless we've done this, unless we pull the ATHOS up, we can't really go through setting up the aircraft for this descent. Since we've obtained the heading or the ATHOS, now we can go ahead and look at what the C means. In our case, C means chart heading. Today, we're going to be professional pilots, and we are going to go ahead and use the Jeppesen charts, and we have pulled up the ILS and localizer to 17 left for Denver international. And we look at the bottom, we'll have a date here, and we might have a date up here, depending on the chart. Usually it's up at the top, but in this case, it says that this chart is effective 11 of December of 14. So we're in a time machine, guys. So 11/14, we'll just assume that this chart is the correct chart to use. We've got some chart numbers up here. We have an amendment 4A, so we can verify with two pilots, one getting his chart up, the other getting his chart up, and we can make sure that both charts read exactly alike so that one pilot doesn't actually accidentally get onto the wrong chart. Then we move on to the F in the CFI portion of this acronym. And the F stands for frequencies. So the first thing I'm going to be interested in is I want to make sure that we get the right frequency into our navigation radios. And I can look here, and because I have the chart up, I can see that the navigation frequency for this localizer is 110.15, and put this out, I can see that the identifier for that frequency is IBXP. So now I've confirmed that frequency. I'm also going to go ahead and take note of what the control tower frequency is, or the common traffic advisory frequency. And if they have a ground frequency, I'd like to also write that down on a separate piece of paper, so I have it handy when I need it. And I can find the ground frequency right here and the tower frequency right here in the briefing strip portion of the chart. Okay, let's pull this out of the way, and let's go ahead and, while we've got it up, we just as well put it in to the FMS. And the way I'm going to do it is I'm going to go to the index button. I'm going to go to the database. I'm going to take a look at KDEN, the airport we're going to. Click on that, take a look. Yep, I've got the airport database up. I'm going to click on localizers, and I'm going to take a look here. And yes, indeed, I do see the frequency and the identifier for 17 left in my database, and it checks out to be correct. So guess what I'm going to do? I'm going to go ahead and I can use either IBXP or I can use the actual frequency. I'm going to drop IBXP down into the scratch pad. I'm going to go over to my radio page, and I'm going to take IBXP, drop it up into the nav1 section, which is L3, and it places it up there automatically for me. And I've already had it in there from before, so let's go ahead and drop it back down into the scratch pad, and we can actually move it over to R3. So that's already in there for us. I feel good about that. Now, let's move on. I've written down the tower frequency. I've written down the ground frequency. I held it off to the side, so I don't have to refer back to the chart for that. The inbound course is the next thing I'm going to want to go ahead and set up. And in this case, the inbound course, if I look at my chart, is 173. So the inbound course is there. I take note of it. I bring it down, bring the chart out of my way. So, whoops, let's get rid of that. Now let's bring the chart down out of my way. And now I need to put it in my localizer navigation mode. So I'm flying along here in FMS1. I do not want to take myself out of FMS mode when I switch over from one source, nav source, to the other. So what I will do is I will take my flight director arrow here and I will transfer it to my co-pilot side. And now we will be flying in FD2 while I change my nav source. My nav source comes up as localizer 1 because I'm on the number 1 side of the aircraft. I would then put my course in. As you can see, it's already in there, but I'm just going to show you. You go up to the course selector knob. You can change that course, and 173 is correct. Localizer is in red because we're outside the service volume range of the localizer, so it's not actually picking up the frequency that we put into our radio, our nav radios at this point in time. As soon as we get within the service volume range, this should turn green for us, and we will be set up for the approach if we switch back to the localizer mode. But for the time being, we're going to change our nav source back to the FMS and switch the controls back over to the number 1 side, not ever having left FMS control of either 1 or 2. So the airplane's still happy. I'm going to take us out of freeze so we can put on down the road here. As you can see, we're heading towards Othi. Our speed is good. I have no trend indicator on the airspeed, so I can kind of take my eyes off of it for a little bit. And moving on, the next thing I'm going to look at are the heights on my flight. Now, what heights am I specifically interested in? Well, for sure, I'm interested in the minimums that I'm going to fly down to. That's a height. So we're going to be shooting an ILS, so I'm going to be looking for the DH, and I see the DH is right down here at the bottom of the chart at 200 feet. I can also see what my touchdown zone elevation is, and I can take a look and see what the elevation is approximately 5 miles from the airport. So there's 3 heights that I'd really kind of like to be interested in. So I've got 200 feet on my DH. Let's not forget to put it in. Coming back, and I'm just double checking, make sure everything's in the correct place. And I'm going to come over here and put my DH in. I've already previously done it, but we would do it by going down here to the DH knob. Make sure the knob is in the DH mode. We can change our DH up here on the screen. If it doesn't show there, for example, like that, we could click on the DH and put it in by a real quick click on the knob, turning the knob right or left. So now I've got my DH in there. I'm still remembering I've got 7,000 feet at my final approach fix, and I'm going to pull the power back here just a little bit, and we'll see if that trends in the correct direction. Okay, so I'm going to come over here to my legs page real quick. Just going to double check. I'm going to go to the next page, I can take a look at 17 left. I see Irene is about 5 miles from the end of the runway, and it is saying that I'm at 7,000 feet when I get over Irene. So Irene, 7,000 feet, that's good for me. I notice that Othi is flashing here. That's fine. A little alert to let me know that I'm getting close. And again, I have my touchdown zone elevation. The next thing I'm going to be interested in looking at are my obstructions along the on the approach area. So I would take a look right off the bat and brief my MSA, my minimum safe altitude, in an area 25 nautical miles from the Denver VOR. It says that if I'm above 90 or 9,200 feet or above, I'm not going to hit any obstacles. On some approach plates, you'll see that there's a dark arrow pointed at maybe a tower, and that would be the highest obstacle on approach plate in view that you might be running into if you go below 9,200 feet. The next thing I'm going to look at is my missed approach procedure. My missed approach procedure simply says climb to 5,900 feet. When climbing, then climbing a left turn to 1,000 on a heading of 120 and into the fix out here looks like it's FQF on the radial, Vortac radial, the FQ radial of 078 and the Limix FQ39 DME. So I can pick out a point out here for my hold, which should already be programmed into my FMS because we put the approach in earlier today. The next thing and most important is finally brief my exit. That's what the E stands for. I would pull up the airport diagram page and I would take a look, see what I think, where I think I was going to exit. And it might be somewhere down here if I were actually looking at the airport view. And then I'd be coming back up here because I know these taxiways come across the end of the runway and come on in into my gate area right here. So I'd review that quickly. I'd know where my exit was for the runway to get to the taxiway that I want to get to so I can make it an easy taxiway to the gates. So now we've briefed everything up. We've got everything set into place. We can pull our approach plate out of the way. We've taken the notes off of it that we need to have. We've programmed the computers in the aircraft. We've set up our inbound courses. We've set up our radios and we've briefed the chart. So let's move on from there. The next item is to go to step number 2, and that is to determine what our final approach speed is going to be. Now, today we do not have approach cards in the aircraft, so we're just going to simulate some of this stuff. But in the actual simulator or aircraft, we would have approach cards. So to determine the actual landing weight of the aircraft, we would take our zero fuel weight and estimated landing fuel, add those together to get the weight of the aircraft on landing, which is the weight that we're actually looking for if we're trying to determine what our approach speeds are going to be. If I were looking at the pilot monitoring's MFD, it would look kind of like this. And it would show us a number right here on the pilot monitoring MFD. That is our estimated landing fuel. That's how much we plan, the computers plan to have on the aircraft when we touch down. The other number I'm going to be wanting to look at is the number that we find on the performance init page, and that's the zero fuel weight in this area. And when we know where that's at, now we know the landing fuel weight and the zero fuel weight. We can add those together and get our actual aircraft landing weight. Once we have that weight, we go to our flip cards, which of course we don't have. We review the flip cards for the landing weight, and from that flip cards, we will get what we call a VREF number, a VREF speed, and that is the minimum speed at which we can fly the final segment of the approach. Now, we're pilots. We want to be a little safer. We don't like to be that close to the edge of the envelope. So we are going to always add a wind factor in or add an approach factor for our speed. So how do we do that? We go back to our ATIS. We look up on the ATIS and we happen to have found out already that the wind We're landing runway 17 left. The wind is 170 degrees, 12 knots, gusting up to 20. And from the VREF cards, we found out that our VREF speed was 128. So the rule that we're going to use is this. There's two rules here that we need to combine, and the way we do it is this. We take 1/2 of our steady state wind, which is, our steady state was 12 knots. 1/2 of that is going to be 6. And we will take our full gust factor, the difference between 12 and 20, which is 8. Add those together, and we get 14 knots. Now we check something else. We want to make sure that we always add at least 5 knots. Even if the winds were calm, we would always add 5 knots to our VREF speed. We never add more than 20 knots to our VREF speed. So we're going to be adding somewhere between 5 and 20 knots to the VREF speed. And in this case today, when we calculated what the actual winds were doing, we came up with 14 knots. So we take 128, which is our VREF speed, add 14 to it, and we end up with 142 knots. And that is equal to our VT speed. All right, so I see I'm getting a little bit closer here to my top of descent. That was calculated by the FMS. I still don't know for sure if that's correct. So I'm going to go ahead and freeze the flight for the time being. And now I take a look and I say, okay, my VT speed was 142. That's the speed I want to use to fly the final approach segment of this leg. So I come over here to my V speed. I verify that I'm in V target. I go ahead and select V target here, and it's seen over here, so I can rotate it around, get it to 142. And I select the select button, and that places it somewhere on my speed tape. Since I can't see 142 on my speed tape, I can be assured it's on there, and I've done that. So now I have my VT set up. So that part's done. That's step 2. And then I move on to step 3 and step 4 for that matter, since we're on that page now. What we need to do at step 3 is validate that our top of descent is correct. And right now, the top of descent that I see calculated by the FMS or generated by the FMS is right here. That's where I will start my descent. Now, if I went back and I looked at my legs page and I go to next page, I will see that we have pre-programmed Dandy to be crossed at 250 knots at 6. Actually, let's make that 17,000 feet. It's a good thing we checked. I'm going to put a slash. I'm going to go 17000 and drop that into there and execute it. So apparently we didn't look over our flight plan well enough when we left Salina. So we make this correction now. No big deal. We weren't cleared to do this yet anyway, but we're going to anticipate it. We're going to plan on doing that because that's the numbers that are on the arrival. 250 knots, 17,000 feet. Plan to do that when we get to Denver. So we're going to set that up right now. And we don't know for sure if this is correct. It probably moved a little bit when I put that new number in there. So no big deal. We're going to double check it anyway. So I don't trust the FMS. If I made a mistake, it would be erroneous. And what would result is I'd start down too early or too late. Either one would be good. If I'm too late, now I'm going to have to hustle down. If I'm too early, then I'm going to get down too soon, and I'm going to burn more fuel. Good practice is to back the FMS up with a rule of thumb calculation. This is what we call our 1 to 3 descent, which means for every 1,000 feet that we descend, we're going to travel forward by 3 nautical miles. The example here we're using today is we're cruising along at flight level 280, and the planned crossing altitude for us today, as I indicated, was we're going to plan to cross Dandd at 17,000 feet, 250 knots. And our descent speed will remain at 290 knots as we descend down the imaginary slope, which is our normal descent speed. And we will calculate these calculations to verify our FMS top of descent. 2 rules that we have to understand is we have rule number 1 is our miles that we're going to travel forward during the descent. And then we have to also calculate miles that we have to slow to get slowed down to 250. So first of all, let's take a look at the altitude we're flying at 28,000 feet. We will drop the zeros. We're going down to 17,000 feet. We will drop the zeros. We will subtract 17 from 28. Gives us 11,000 feet that we have to descend. Then we're going to multiply that 11,000 feet by a factor of 3, which is our 1 to 3 rule. 11 times 3 is 33 miles. So we're going to have to start down at least 33 miles prior to Dandd if we expect to cross Dandd at 17,000 feet. Now, that is only if we're not planning to slow. But in this case, we're actually planning to slow prior to reaching Dandd, because we have to be 250 knots when we hit Dandd. So the 33-mile calculation isn't going to be exact. It's just going to get us down from 28,000 feet down to 17,000 feet, but we still have to calculate a distance to slow. The rule is that it takes 10 knots. It takes 1 mile to slow for 10 knots when we're at idle speed and level flight. So here it is. It takes the distance it takes to slow at idle thrust is approximately at idle thrust 10 knots for every 1 mile in level flight. So once we hit 17,000 feet, we're going to leave our thrust levers, in this case at idle, and we're going to cruise along at 17,000 feet. And we want to slow from 190 to 250. So we're going to subtract 250 knots from 190 knots, which leaves us 40 knots to slow. We have 40 knots to slow. We divide it by 10, and we come up with 4 nautical miles. That's the math. Okay. So now we take that 4 miles and we add it to our 33 miles that we calculated for the descent, and we come up with 37 miles that we need to plan our descent from Dandd. So that's great. 37 miles from Dandd. We will go ahead and set 17,000 feet in our window up here for our altitude, and we will hit the descent button, and we will pull our power back, and we will start our descent. But the problem is, how do I know where 37 miles is on this? So I do it this way. I will take Dandd down to the scratch pad. I will go to my fixed page. I will put Dandd up into my reference, and then I will put 37 miles into my distance crossing, and voila, I get a ring from Dandd. Let's zoom out a little bit. There's Dandd, and I can see my aircraft's here. So when I cross that ring, I need to start down. Now I'm taking a look at the FMS calculated position, and it's just a little bit off. I'm just going to double check my altitude that I have in here for my cruise. That will be on the performance page, the performance init, and it says 28,000 feet. So I'm going to guess my calculation is probably off about a mile. I'm going to trust the FMS because I can see it's pretty close. So at this point in time, I'm going to use the FMS, and I'm going to clear out what I have in on my fixed page. I'll just delete it, delete in the scratch pad, clear that out. My ring goes away. I'm feeling pretty good about that. I'm going to unfreeze. I'm going to let the aircraft continue on its way to that point. And when I get there, we'll start down. I have one last thing to do. I need to set up a 6-mile ring around the final approach fix area. And I can go into my legs page, go to the next and next. And I can see that there's runway 17 left. I see 5 miles here to Irene, or Irene, 5 miles to the runway, 7,000 feet. I like that. Looks good to me. That's where I'm going to go ahead and put a ring. I will take Irene, drop it down into the scratch pad, go up to the fixed page, take Irene up to the fixed page, circle it with a 6-mile ring. I'm pretty comfortable that it's going to be there. And I will just, I'll let it go for a little bit longer here. Let's go to change my format here to my plan up. I can see the ring is there. I'm going to zoom in just a little bit. Since I'm in my plan view, I will go back to my legs view here. I will run my cursor down, and I see that I do have the ring around Irene. And this ring is good because it's not only, it gives me situational awareness, but before I hit that ring, I want to be going no faster than 200 knots. And I do not want to be any higher than 2,000 feet above Irene. So the altitude limit for this ring is 9,000 feet. And I would want to stay above Irene at 7,000 feet. So it gives me a little situational awareness there as to what I'm going to be looking for. This is so that I can get my aircraft on speed and fully configured before I get to Irene and shoot the approach. So 200 knots, that's my speed limit before I hit the ring, and no higher than 9,000 feet. I prefer to be at 7,000 feet. Okay, let's take it back into the correct format. I'm going to go back to my MFD, put myself in VNAV, and I'm going to go back to the legs page. Also going to see that I'm coming up on my top of descent in about, looks like 7 miles. If I wanted to go up here, I could look. Top of descent is 8 nautical miles. It just switched to 7. And that's about what it looks like on the ring. I'm going to go ahead and increase my view here, increase my range. Went the wrong way. There we go. And I can watch up here, watch the countdown here, or I can just watch my top of descent here. And I'm golden. What am I going to do? I know ATC just gave me a clearance to cross Dandd at 17,000 feet at 250 knots. So when I hear 17,000 feet, I change my altitude, bring it down to 17,000 feet. It's still got my altitude captured because it says altitude was captured here. I'm at top of descent. I want to do 290 knots. So if I click on this descent mode button right now, I see it took 288. I increase the speed back up to 290, and I pull my powers back, throttles back to idle, and watch the aircraft descend. As it's descending here, I can increase my range. I can see I have my little location here on the arc where I'm going to end up at this descent rate, at this speed. Notice I'm doing 290 all the way down. I will do 290 all the way down to that arc. And when I get to the arc, I'll start slowing to 250. We can watch this do this if we want. Now I'm already briefed up on the approach. I've done all the stuff I need to do. So one thing I can do, I like to always keep my heading bug straight ahead. So I hit the heading bug, bring it up straight. I'm still in FMS mode. I'm in descent mode, 290 knots. So it's pitching to 290. I have the throttles at idle. This is what we call an idle descent. And looks like I'm going to have a good, easy 4 miles before I get to Dandd. Now the trick here is to make sure I definitely cross Dandd no higher than 17,000 feet. In fact, I'm going to cross it at 17,000 feet. So what's going to happen is I'm in the descent mode. Altitude is armed. As soon as I get to 17,000 feet, altitude is going to turn green and replace my descent mode. And since I still need to slow to 250 down here somewhere, I'm just going to let the throttles lay back in the idle position until they get to that slowed down speed. And the aircraft will slow down like I want it to. Then I need to add power when I get close to 250. And all I'm doing now is monitoring this. I'm going to go ahead and decrease the range just a little bit so I can still see where my arc is. If I got a little bit behind right now and I really need to get it on down a little faster, I could pull out the boards or the flight spoilers. As you can see, watch what happens to the arc as I pull the boards out. You'll see that the arc gets closer to the aircraft, creates more distance. I really don't need it, so I'm going to put those spoilers back in because they're just creating drag for me, and that's costing me money. Got a couple thousand feet left to go to 17,000. If I can go back up here and look at my altimeter setting that was in my ATIS, it will say that the altimeter setting is 2990. I'm going to cross through 18,000 feet. I'm going to change my baro to 2990. And I'm going to start doing that now just so I have it in there as I cross on down through 18,000 feet. As you can see, it's already set. And now 18,000 for 17,000. That's an announcement that one pilot would make to the other pilot. Altitude should start flashing. Altitude is captured. I'm going to start bringing in my thrust lever so I can maintain. Actually, I'm going to pull it back because we're going to slow down. So I'll let it go ahead and slow down. Altitude is captured. It's going to hold the altitude and it's going to start slowing down to 250. I can see my trend line here. That's a 10-second trend line. Where it's pointing here will be 10 seconds later, what the speed will be. And I'm well ahead of Dandd at 250. So I'm going to start bringing my speed in. Oops, let's keep this power back. Let's dial my speed back to 250 so they match. And now I can bring my speed in, or my thrust levers in, to maintain my speed at 250. Here's Dandy. Dandy right now is, looks like 4 nautical miles away. I'm good to go. I've completed the procedure here, crossing Dandy at flight level 17,000, and I'm on speed at 250, exactly what my clearance said to be. Hope I made that look a little easy for you. I'm sure you guys will get just as proficient. Do a little practice with this. Make sure you learn how to use the document here. Make sure you know how to set up using ACFI Home. Thanks for watching. Keep the dirty side down and the shiny side up, and we'll see you next class period.